So, I'm Joy Reidenberg, and I'm going to speak to you about to draw or not to draw. That's the question. Because there are a lot of pros and cons to hand-drawn illustrations versus digital photography for anatomical figures. And those of you who are artists in the audience, don't worry, your jobs are not at stake just because there are digital cameras out there, because each one of them has strengths and each one of them has weaknesses. But in particular, what I really want to focus on is how the artist sees an object versus how a camera sees the object. Because I know you don't like hearing this word, but we as artists are prejudiced. And this is a good thing for an artist. It's not a good thing socially. You don't want to be prejudiced. You don't want to have, those biases that make you discriminate against certain individuals. But as an artist, you're full of biases, just like everybody's full of biases. Only your biases have to do with the perspectives that you bring to an object that you look at. So what I'm going to do is show you how we dealt with that particular issue in doing some medical illustrating for an article that I was doing for an anatomical dissection of a whale, of all things. Yes, I do work on some very strange animals. And one of the things I do is I look at whales and dolphins and porpoises, and this happens to be a pilot whale. And as you can see from the dissection, which is shown on your left, that's a very important image for me because it has all the data that I want to show. But it's not easily visualized by a viewer who isn't actually familiar with the object and can't see it in 3D. And often can't see it in color depending on your publication restrictions as to whether you can publish in color. So therefore, having a drawing that simplifies that is essential. And that's what an artist can do that a camera can't do. Because a camera doesn't know how to discard the unimportant information and retain only the important information. And a camera can't get rid of the distractions, the shadows, the glare. You can try to patch those things up on Photoshop. But an artist can do all of that because an artist can synthesize from that actual image or from the actual specimen what the important information is with, in collaboration with the scientist who says, this is what I want to show and this is what I don't want to show. And they can then simplify it. And it's all about simplifying that view to make it more comprehensible. And then you can even add color, as we did in this particular image, to say, okay, the real target is that little bone that's in the middle of all those different muscles in there, which for those of you who actually care about all of that, that's the hyoid bone. I don't see a pointer here. There is a pointer here? Okay. Let's see if we can get it on. It's on. Okay. So this is called the hyoid bone, and this is what that bone looks like if you flip it around, so it's not in the same orientation anymore. And all of these muscles are attached to that bone, and they're moving it up, they're moving it down, they're moving it back and forward, and all these different things. So it's a hitching post. So it's really important. But this is a very static image. A video would be better because then we could show it in all different ways. But until recently in publications, we didn't have the option of a video. We only had the drawings. So digital image technology, it's been a revolution for all of us. We can simplify visual data and record it as a digital format where it's now manipulatable. We can generate higher resolution images than ever before. We can get digital measuring of geometric parameters that are in there. Of course, using a camera means everything is fast compared to having somebody illustrate it and doing it by hand. So you get very fast image production. And now without having to worry about developing film, it's even faster. And of course, you have all of those things you can do in Photoshop or Illustrator where you can manipulate the image, contrast, brightness, skew it, whatever it is you want to do. All of those are possibilities. So I just listed a few of the things you can do, but I'm sure if you go down the list in Photoshop, there's a lot more things you can do than even that. But the question about that most of us have in research is this a fail-safe method? Is it okay to just use digital images? Are they really the truth with a capital T that we're all looking for? So in other words, how accurate is the digital photograph when you compare it to the traditional methods of illustration, when you're reducing what is essentially a three-dimensional object to a two-dimensional figure? So what are these advantages and pitfalls of using hand-drawn illustrations instead? So let's start with a digital photo of a dolphin skull. So an artist that was working in my laboratory did an outline of this skull, this actual specimen. And I brought the specimen with me. I'm going to go behind the curtain here. Don't worry, I'm coming back. I just have to gather all the pieces. And then I'm going to come back. Okay, here we go. I lost one tooth in there. I'll have to remember to bring it back. All right, so I've got here a skull. Oh, that's okay. The tooth can stay on the card. There's a loose tooth. So those of you who are actually looking for details, there's a missing tooth right now. That's okay. So this is that very same skull. It's been through a lot in our lab. I'm going to put it together here. Stick the back of it on here. So you can all see that. I hope that for maybe some of you around the corner there. One more thing. I'm going to get in here. Okay. And the way it happened to have been propped on the shelf is the mouth is open because we had something underneath there, something like this. Just propping it. Well, that happens. It's okay. I got more. So that's one of the problems with working with this material. Is things do tend to do that. Okay. So this has been glued 6 times already at this point because students play with it and it falls. And so I'm not too worried about that. So don't get upset. That's why we use these specimens. This is one that doesn't have any data. So we're like, okay, it doesn't have data. We can play around with it. So that's why I brought this one. I'm just trying to get this cork to go in the right place so I can hold it for you. There we go. Okay. So that should look pretty close to what you saw. I'm just going to leave this delicately balanced here, and hopefully it won't fall again. Okay, don't be nervous. You know what? I'm going to leave it off. Then you won't have to be nervous. But you get the idea. That's the actual skull. There it is up there. And you can see even in this one, you see it was cut here, and it's actually been glued here a couple times. So it's been through a lot even before I brought it here. So what we had the artist do was to take this skull, look at it, and just draw it freehand. That's what I wanted him to do. So we also took some digital photos at the external surface of the head of that dead dolphin of the same species. It wasn't the same animal, but it was of the same species. The artist did not see the original specimen, but drew the dolphin's outline from this 2D photo. So this is the same species. This is not Flipper, the bottlenose dolphin. Okay, this is a different kind of dolphin. It's called an Atlantic white-side dolphin. And one of the main differences is that its forehead seems to come a lot closer to the front of the beak, whereas in a bottlenose dolphin, it goes way back and then up here. That's the one you're used to seeing usually in drawings or in illustrations or in films even, because that's the one you'll see in the aquarium. But this is a different kind of animal. We were doing some experimental work with these animals, and we needed some drawings of this particular species. So I gave him this photo. He wasn't able to see the actual specimen because I didn't have that specimen in my possession. I'd worked on it somewhere else. So I gave him this photo, and he made his outline freehand from this as well. And he put them together to make this drawing. So this is the artist. His initials are down here. His name is Noah Ash. So that's anytime you see the drawing with that on the bottom, that's his drawing. So this is what he drew. And as you look at that and you look at this, you say that's actually a pretty good representation of that same animal. We've got that short beak, the nice round forehead up here, and there's the skull inside here in all its glory with its lower jaw, with all the teeth this time, without the pieces missing back there. It's okay, not to worry. And then what we did is we took the outline of the head of the dolphin, of the actual physical dolphin. We actually drew an outline, traced it right on top of the digital photo, and kept just that tracing. And we aligned that green tracing on the drawing and scaled it, aligned it with the rostrum. So can you see that green showing up on there? And it actually was pretty good. I was stunned at how good his freehand drawing was, matched to that photograph. And I'd asked him to look straight on at the dolphin skull, but you couldn't look not straight on at the dolphin head, the physical fleshy head, because the photograph had limited his perspective of looking at that head just straight on. And so when I looked at what he had done, and we had to, of course, play a little bit with the enlargement, but we didn't want to skew it. We didn't, pull it and distort it horizontally or vertically. We just pulled it from the corners, keeping those proportions fixed. And it matched really well. I was stunned at how well it matched. But then again, the artist was working from a two-dimensional object, this photograph of a dolphin's head. So that worked. That's why it has a little green check. Then we said, okay, let's test how he did on the skull, because that was a more challenging object for him to look at. Because there he wasn't given a photograph, he was given the actual skull, this very skull that's right here. So we took the digital photo of the skull from the same perspective, looking straight on, and you can see it sitting on the shelf along with other specimens in the lab. You know, it wasn't like it was a beautiful background where it was nice and plain and easy to see. And made the tracing of the skull. He did the same tracings, by the way. He did his tracings as well. So he's double-checking his own work. And then came the challenge of overlaying the tracing with his drawing, as well as the tracing of the dolphin's fleshy head with his drawing. And those of you who are really adept at looking at this will notice that we've lined it up as best we could on the rostrum. This is called the rostrum. And then we lined the top of it as best we could with the crown. So we had to do a little bit of proportional scaling, not disproportionate, always keeping the proportions of length and width, you know, properly matched. And we enlarged it and tilted it until it fit the best fit we could get between basically this point and this point. And what we were able to see is that the back of the skull in particular really didn't line up very well. So this area down here was particularly bad. Bad is a subjective term. I wouldn't say it's bad, but it wasn't the same as the drawing. So this part was really sticking very, very far out. The jaw was very, very different, but then again, look what I had to do to try and get the jaw propped here. So the jaw was a variable component, as you would expect it to be, because it is something that could be moved around. And whatever was happening with the dolphin head in the flesh was not exactly the same as what was happening with the skull and how it was positioned on the shelf. I keep wanting to click it on here, and I realize it's not attached to my computer. And then, of course, because of what I just said, that jaw is mobile, I wasn't too surprised that the jaw on here didn't fit with that, because he was trying to fit his dolphin within the head he had drawn. So that's actually a fixable thing. And if you look at the very back of the skull, that's the part that fell off over here, which has been glued a gazillion times. It's even got tape in the back, by the way. So it's got other cracks in it, too. So this thing back here didn't exactly match either. And then in the very, very front, this part of the crown, this didn't match very well. Now, some of that could be because he's looking over the top of the skull a little bit, whereas the camera might not have been. What's going on with the side? Why was there such a big mismatch on the side? Is that he was probably looking around the corner there as well. So we now took the skull, just the skull tracing, and the skull itself, and overlaid that on the photo of the head. These are not from the same individual animal, but we overlaid them. They're from the same species and from animals of the same sex and the same length, so we expected them to be fairly similar. So we made the assumption that they were identical, even though they're not. And we lined up that skull as best as we could with the rostrum of the animal here and the crown of the animal here. The head actually cut off here, but we have the rest back here. So we have the skull sticking out, even though it's not on the specimen on the photograph. And then when you look at the way this is lined up, you can see because we didn't have these teeth meshing, of course, that jaw could be in pretty much any position because it's not articulated here. And it was sticking out too far from the lower jaw. So what we did is we realigned it. So now it's perfectly aligned. We've got the lower jaw aligned, we've got the upper jaw aligned, all of the teeth are in approximately the same positions, the crown is in the right spot, the occiput in the back here where it connects to the vertebral column, the spine is in the right spot. Everything looked perfect, and we were like, okay, that's what we really want for our drawing. So we just took the tracings and got rid of everything else, because that's really what the artist wants to do, essentially, is get rid of everything else and just show us the simplified version. So in this simplified version, we just have lines. And so you can keep track of them. Remember, the pink one is the skull, and the green one is the fleshy animal, and this is before realigning the jaw. So you see how they didn't match up over here. And now we're going to take those two parts that weren't exactly synced. Also, this area here didn't line up pretty well. We had a problem with that lining up with where, see, there are teeth down here, but the teeth are up here on the animal's head. So we knew that jaw needed to be repositioned. So we digitally repositioned it, because you can do that. That's the fun thing about digital images. You can make them into separate layers and move each layer independently. So now everything looks like it's working. We were all lined up in all the different places. But then we got rid of the outlines. Let me go back one. See here the outlines of the animal's head, and these are the teeth themselves. They're not bad. They're actually really pretty well aligned, because they're not even the same individual. But we took off the green teeth just to make it simple, so we didn't have shadows on our teeth. And this became the template that we were using for the rest of our drawings. But I was still concerned about, how did that match with the original artist's drawing? Why were there so many differences in there? Of course, once you've got your template, you can play with it. You can go crazy with the colors if you want. You can add all kinds of things to it. You can shadow the skull in different ways. But what we essentially really needed to do is go back to that animal. This is that animal you saw before. This is that same animal during the dissection. Once we dissect it, there's no going back. We can't go back and recheck anymore. We've taken that part off and it's been disposed of. So that's why we have to accurately record it in as many ways as possible. And one of the problems with digital photographs is you might only have one view with your digital photograph, and you can't go back and reconstruct that again unless you have all of the photos of all the different perspectives that you might want to have. And that's laborious because they're not sitting there taking 360-degree angled pictures of every step of a dissection. So now we're stuck with, we want to animate this, or at least turn it into an image that's comprehensible by the lay public. So I apologize for those who just ate and now are getting squeamish. But this is the meat and potatoes of what we're looking at. This is a dolphin's head that's been dissected into to show functionally what's the really critical important part of this head, which is that there's a whole bunch of little balloon-like sacs underneath its nose, which is up here. That's the nostril or blowhole up here. And then these are air sacs. And these air sacs are sitting on little pieces of index cards so that we can highlight them and get their shapes precisely. But notice this is not a straight-on view. This is an oblique view because I needed to make the point that these were paired, but the pairs were not symmetrical. So there were a lot of other complications we had to add to this drawing. So I wanted to convey this, but I still wanted it in a lateral drawing. And I wanted to get rid of all this messiness. Nobody needs to see all this messiness. Nobody needs to see all this nastiness down here and the eyeball falling out and all the other nasty parts that are happening that don't make for good publications for the public. So this is what we ended up with. This is that same skull that was done from the tracing that was modified from the original drawing. And these are the various air sacs that have been shadowed in, only showing one side. And we have other views, which I'm not going to show today, that show all of the other perspectives in there. And then we needed to add in other things that were not in the drawing from previous dissections, such as what's going on with the trachea and the larynx and the actual passageway to the blowhole. All of these were parts of the anatomy we needed to show. But this was just to give us some idea of where these different air spaces were in that head. So that actually did get published in the record, and the artist did get credit for this illustration. So I thought, you know what, I'm an artist too, and how did I do when I was given the same task? Because maybe it was just that artist. Or is this something that all artists are going to potentially have an issue with? And I would say issue in quotes because it's not bad. It's just artists have different perspectives than cameras do. So this was my drawing of the exact same skull. It was done even before the artist in our lab, before Noah did his drawing. And I'd done it for a different purpose. I wasn't looking at the air sacs. I was looking at this part, which you saw kind of added to the other drawing. So I had added this in from dissection work. But this was my drawing of the skull, also done freehand and done in the 1980s. So before digital cameras. Okay, this was actually a pen and ink drawing. And then it had to get photographed with like real film and put on like real photographic paper and all that process that we don't do anymore. So this was not a digital image. And I thought, I wonder, let me pull that image out and now compare it to what we've done now that we have the ability to digitally match. Because back then, we did not have the ability to digitally match an image. I had to go with whatever I drew, and I published that drawing as it is, with whatever flaws it had in it. That went into publication. And people look at it and go, that's really what it looks like. And now I look at it and go, it's not exactly what it looks like, because that was me, the artist, interpreting it. It's not the actual data. So if I overlay Noah's drawing on top of my drawing of the exact same skull, look what happened. Okay, I know it's maybe a little hard. Can we shut the lights off in the very front just to make it a little easier for maybe people to see? I'm going to go backwards one. That's my drawing. And I've ghosted Noah's drawing on top of mine. So mine kind of disappears, but a little more on your screen than it does on mine. so I apologize. But hopefully you can see in the back here, my skull ended here. Let's go back one, and you can see. There's where my skull ended. Okay, so where my pointer is. So it's very different from where his skull ended. So we've got some differences. Now, of course, I drew mine for a bottlenose dolphin, so the head outline is definitely not matching. But I also did not have a fleshy specimen to work from at the time. So I was using the skull just as a model, but for a different species. So I had multiple flaws in my drawing to begin with. But just looking at that same skull, I aligned his drawing and my drawing on the rostrum and the crown. Used the same alignment points. But look at how much further out his drawing went. His skull completely covered where the larynx was. Whereas to go back to my drawing, my skull did not cover this part of the trachea or the larynx. Let's lay on top of both of those the line drawing. And there you can see the line drawing. You can see where Noah's drawing is, way out over here, past the line drawing. Remember, mine was further in, just to reiterate. So Noah's was actually a little bit longer, that means greater than, right? Longer in the horizontal plane than mine was, or than the drawing that was done from the tracing. And it was also taller in this vertical plane. And if you put mine back in that area, maybe you can see the outline of mine relative to the pink. I apologize, this really isn't as good as it looks on here. I don't know why, maybe the red color is not showing up so well. But on mine was actually shorter in the horizontal plane, and it was also short on the vertical plane. My skull ended way up higher compared to Noah's, which you can see parts of it right down here, went way down over here. So there were huge differences in these skulls in terms of how we saw the same thing. And what we see is that both methodologies, either hand illustration or digital photography, were going to introduce some morphological distortions. What was the problem with the digital photography? Well, we'll talk about that. So they introduced distortions when you're creating a two-dimensional object from a three-dimensional object. A hand-drawn illustration made from a 2D photograph was more accurate than a hand-drawn illustration made from a 3D object. And we saw that from Noah's work. His drawing of the flesh of the animal's head was spot on. But when he was presented with a 3D object, reducing it to 2D for an artist is a lot harder than it is for a camera to do that, because a camera is naturally only going to see one perspective. This is what the artist is doing. The artist is looking around the corner. They're not constrained. Their head is not fixed on a tripod so that the head is always looking in the same position. So the artist can look around the corner and see this part of the skull right here, which I'll hold this time, okay? This part of the skull here, and you can see, yeah, there's more in the back, and incorporates that unconsciously into the drawing. So unlike photos, hand-drawn illustrations can incorporate multiple perspectives, kind of like Picasso, where you can see the side view and the front view at the same time. That's not wrong, it's just different. Maybe it's right because it has more perspectives than a camera can give. And when you think about when you're doing art, you're not meant to duplicate the camera as an artist, because if you did, well, then you don't have a job, because the camera's already doing that. As an artist, you have to do more than what a camera could do. You have to be able to take that image and give more to it than what a camera alone can do. So, are these artistic renderings accurate representations? It all depends on how you define accurate. So, is that an accurate representation? I can mosaicize this, and that is a perfectly good representation. It just shows me different information, like, you know, different contrasts of color in there, but not necessarily the shape of the actual object. And I can texturize it. I can play with all these different media and make that skull look like it's made of plastic, or make it look like it's behind glass, or make it into like a watercolor or a paper cutout, or a charcoal drawing, or any of these various crazy things that you can do with all of the programs on the digital programming that we have. And none of them are wrong. They're just all very, very different. But remember, there's also problems with digital images, because are they accurate? Really, that depends on how you post-process that image. And even how you took that image to begin with. Did you take that image in the right lighting conditions? From the right perspective? Were you straight on, or were you on an angle? Do you want to convey movement in there? There's all kinds of things that a digital camera might not do right if you don't set it up right. Maybe your brightness is too high, right? Or maybe it's too low. Or maybe your contrast is set too high or too low. Or the saturation is too high or too low. Or maybe you've stuck on different filters later to make it look like a sepia photograph from the old days. Or maybe you've taken out some of the shadows and added too much highlight, or changed the coloring. In the old days, we used to have to worry about what kind of film we put in the camera. Was it daylight film? And then all of a sudden I was taking a picture indoors under fluorescent lights, and like all my specimens were looking blue because I had the wrong film in the camera. So today you just flip a little switch on the Photoshop and you can make it blue or yellow or green or whatever. You can skew it, you can distort it in all different kinds of ways. But the most important difference really is the field of focus. And I find this to be the most fascinating difference between cameras and people. So when an artist looks at an object, the artist sees the entire object in focus. I mean, assuming they don't need glasses and forgot them. But they see it in focus all at once because your eye is constantly accommodating. Kind of like the talk we just heard, where the eye is moving all around the object. The artist's eye is moving all around the object. The camera is pointed in one point, and that's the focal point on the camera. The artist can track all over that object and see all these different things, and then incorporate that into a perspective that gives a very equivalent of a wide depth of field of focus, kind of like opening that aperture. But if you don't open that aperture, you're going to end up with fuzzy teeth, and fuzzy crown, but okay, this part will be in focus because that was closest to the camera in this particular focal range. So now we have cameras that can actually adjust for that. Really interesting. This is a special kind of camera that can take pictures at many different levels and then sum them together. So this is what a typical picture would look like if you just took it with your snapshot with your camera. This happens to be of a dissection, for those of you who care, of a cat in the area of the clavicle. There's the clavicle, then there's this interesting fascia that they wanted to capture, but they needed to capture the fact that there was a muscle here that was reflected and another muscle here that was not reflected. And notice this one is completely out of focus, and this one is in focus because this is closer to where the focal plane of the camera was fixed at the time. So this is called an extended depth of field microscope, and this is not the same picture. This is an eyeball of a fly, and they took pictures of the eyeball at many different levels of focus plane as they went through, and then digitally summed them into a composite image, and then adding some other features of topography, come up with this three-dimensional image, which is not so well appreciated here, but when you put on the 3D glasses, it's like crazy, and you get all this, things are popping out in all different directions. But it is actually a little more 3D than any one of these slices, because if you look at this, or even at this, you'll see that this is all in focus, whereas here this is out of focus, and that's in focus, and now here this is in focus, and this one has only that and that in focus, and so on. Each part of the eye, as they did pictures, was in a different plane of focus. So now here's that dissection again. This is the original out of focus, in focus, and here in focus and in focus, which you can't easily do on the microscopic level when you've got a really narrow plane of something very, very small. So what are these pros and cons? We've got hand illustration variables. Perspective distortion is related to the artist's angle of view. The artist can sum multiple views into one image. Sum the focal range, the lens shape, and the position equivalent of a camera. Correct for brightness. Your pupil does it automatically, depending, like right now we're in a low light condition. There are errors in fidelity of reproduction. The hand-eye coordination can often, give some errors in that. And the reduction of the object to a cartoon outline creates some errors, but at least you can do that, whereas the camera can't easily reduce something to a cartoon and simplify it. Digital photographic variables are, you've got perspective dependent upon the camera angle, and that's a critical thing, because if you don't line the camera up right, you don't necessarily get that sagittal view if that's what you're going for. Variations in the range of focus related to the depth of field. Variability in the black and white, the brightness and the contrast, or the color fidelity, the hue and the saturation. Obscuring of regions that are hidden in shadow. If it's in shadow, you're not going to see it in the camera, but the artist can see it. And revealing hidden regions with a flashing light. Of course, we don't have a light that flashes out of our eyes like, X-Men or something. So we have to try to, look around and see that area in the, in the darkness, but with a flash, all of a sudden things are light up that you wouldn't see otherwise. Photos are fast, especially digital ones, with a higher fidelity of shape and size, especially if you've got a scale bar in there, that's critical, and therefore reliable for recording data. But again, you have to make sure you've got the right angle that you're looking at. If I record these dissections like I did with this one, not on the sagittal, it's really hard for me to then make comparisons between these two because they're not in the same plane anymore. The artist can do that because the artist can say, I see it, and now I'm going to digitally kind of in my head turn it and make it straight again. So the artist can correct the way digital images cannot. Photos have distracting backgrounds. Look at all this craziness going on here. We don't need all that, right? We can digitally take it out like we did here. Boom, gone. Artists can do that too. But if you've got a messy subject like this one, the camera's not going to be able to do anything about that. That's all going to stay. All the garbage that goes with the picture is going to be in the picture. And the photos, of course, are very easily manipulated digitally, which in some cases can actually distort data. You ever seen pictures of gels, people running gels? You know how easy it is to take a little bar of gel and just move it, or darken it, or make it less dark? Every time I see the gel, I'm like, is it real? Did they manipulate it? Because it's so easy to cheat on stuff like that, because all you got to do is play with contrast and brightness, and if you're really good at Photoshop, cut it and paste it and move it where you want it to be. So you can't say the camera doesn't lie. The camera lies all the time if you digitally manipulate it. Hand-drawn illustrations. They will simplify the message for quick comprehension. Illustrations allow selective visualizations hiding the undesirable distractions, and they can show impossible views. Things that functionally are taking place. So we're describing movement, for example. In this case, the swallowing of a fish through this passageway and how things are hooked up together. We're like Superman. We have X-ray vision. We can look inside and just see the parts we want to see. No, there's no brain, there's no skull, there's no muscles, nothing to distract us in there, just the part we want to focus on. Same thing like we saw here with just these sacs, but none of the other muscles. We even broke the jaw off because it was in the way of seeing that sac. You can do that when you have a digital image. You can digitally change it, but the artist can do it even better because the artist doesn't even have to draw that. Just leave it out. This one is drawn by Chris Smith, one of the organizers who couldn't be here today. But he went and did some dissections of dolphins in a lab, and I said, I want a dolphin head, and I want the larynx inside. I want you to show me where the vocal folds are moving. And so he was able to trace this in on top of the dolphin head, all hand-drawn. And then, well, I assume digitally hand-drawn, that version of, not digital camera. This was not done from a photograph. And yet it's remarkably accurate because he's actually had a chance to hold and manipulate that material. So now I want to do something fun. Okay, I'm going to go back up for 1 second. Can we turn the lights on all the way for a moment? Okay, I have about 12 minutes for an exercise. And I'm going to ask Jill. She knows she's going to be put on the spot, but she didn't know what she's going to be asked to do. I'm going to ask Jill to draw this. No pressure. And you're going to draw it on this. And we're all going to get to watch you do it.
It's like a nightmare.
Okay, so let's take this, and I want to put it just to the side so we don't move it all the way back. Give yourself a little room here. You can turn it this way so you can face your subject. We turn your subject for you. You tell me when you've got it in the sagittal plane for you. Like that? Okay, now all we need, you move it any way you want, okay? And all we want you to do is to draw like Noah did and like I did, some quick cartoon outline. Do not worry about all the little details, just the outline. I want just the top, go over the top, come around the back, get in the jaw, throw a few teeth on, whatever you're comfortable with. Now, those of you who want to play along at home, get out a piece of paper and do the same thing. And if you want to get out of your seats and come over here and draw it, you can then compare your drawing to what she's doing. I can't see what she's doing from here, so I'm not even going to be able to bias her by making faces, or whether it's good or bad or anything like that. Now remember, whatever you feel you can do in the next 10 minutes. You have 10 minutes to do it. 10 minutes is a lot of time, right? Done those. No. I got 10 minutes. There's the clock. Take your time. And then whatever time is left over, we're going to do a little like artist critique. Nothing like putting an organizer on the spot, right?
I'm rescinding your invitation retroactively.
Ah. But the idea here is not to, say whether she's getting it right or wrong, but the idea here is that I'm hoping that she has an artist's perspective that's different than a camera would have. As you saw, because I flashed a little too quickly ahead, I'm going to show the digital picture, and we're going to make a comparison, not to see whether she's accurate, but to see where are her biases. I'd like to know which, I assume something is going to be skewed, but I don't know what. And I'm interested to see what is she incorporating in her three-dimensional ability to look at the skull that the camera didn't capture. So her drawing, in some sense, will be more accurate than the camera because it's got more information than the camera was able to do. I just don't know which piece of information she is biased towards and she will want to incorporate. I know when I look at a skull, I'm short. I tend to not always see over the top of things, and so I tend to look under things, and I tend to get more of the underneath view if that's my view, because I'm looking up at the object. If I were tall and I were looking down at it, I'd probably incorporate more of the top of it. If I had the ability to walk around, I'd probably, get more of the back end of the skull. So it all depends on what the view is, and the artist is picking. I'd let her pick how she wanted to set it, what her view is, and we're going to compare it to how the camera saw it. What the camera chose to leave out is you're going to see is very interesting. It has a lot to do with light and shadows. I'm happy to take questions while she's drawing. Yes? What is the skull? I was going to ask you guys, what do you think it is? As I was wheeling it here, I got the answer from a few people in the hallway. They were very sure what they thought it was. What do you think it is? I heard orca from someone in the back. It is an orca. The most common answer I got down the hallway was dinosaur. Well, it is, after all, a medical center, and I used to see whales, so of course they thought it was a dinosaur. Yes?
So a quick question. With the issue of repositioning the skull relative to where it is in the head and trachea and all, why didn't you do the CT?
Well, in the 1980s, we didn't have it. Okay, CTs just came on the scene for medical diagnostic imaging in 1983, I believe. That was the first of CTs. And MRs even later. And when they did, they were extremely expensive. Okay, so yes, we could do CTs now. They're still pricey. But it also depends on the size. That orca skull will not fit in a CT scanner. It's too wide. We can get the front of it in, but this part here is a little too wide. It will actually fit through the tube, but it won't be in the image. Because inside the tube, there's like a margin around that doesn't get captured. That's just for slip through, and anything that would have been captured there is distorted, so it's X'd out of the image. So if I were to image this skull, I would not get an accurate CT scan of it. I have to go to a veterinary medical imaging, thing like they use for horses, or for really, really obese people. They sometimes send to those horse scanners because they can take the girth through it. So that's what I'd have to do with this. Yeah.
I was curious, with extended depth of field microscopy, how many images you have to take normally for one summed image?
I think it all depends on how much resolution you want. So are you going to do every millimeter, every half millimeter, every quarter of a millimeter? Really depends on just how image dense you want that final image to be, because the more slices you take, of course, the thicker the memory you're going to need.
And is that completely automated, so where you're taking shots like every, like a matrix?
So first of all, truth in advertising here, I don't have that machine.
Oh, okay.
Okay, I work with someone else who has it, and I can only tell you what they have shown me, but I haven't done it myself. I just know of its existence and thought it'd be cool to show you.
Yes.
So I think it all depends on how big your specimen is to begin with, as to how many slices you're going to need. And when you set you can set the distance between slices. So if you want a kind of very fast coarse thing, you can set very wide distances and it'll do it quickly. And if you want something that's very fine, then it won't look like a Legos construction when you're done. So the problem with the big spacing is that it looks like you've made the thing out of Legos. And then you've got to smooth the edges. So there's other software to smooth the edges and interpolate the missing data between cubic chunks of whatever it has. So it's basically like making a topographic map, and it all depends on how you set that resolution, how fine it is. The more detail you want, the bigger your image, and in the end, that it has to process, and the longer it will take, and the more memory it will take. So there's trade-offs in time for that. But other than that, I can't tell you more.
But that helps me understand the workflow.
Okay.
Maybe
Whenever you say you're done, whenever you say you're done.
I can start editing like little rolling pictures. I mean,
It's awesome. Oh, I love it. Okay, so then we're going to move this over here. Okay, right here like that. We're going to bring this over here. I don't know if it's going to cover the screen. Those of you over there see it if I do it like that? All right, let's take a look. Now that's the picture of the same skull in my lab. And because I think it's very hard to see some of the darker areas in here, what I did is I digitally took away the distracting background. So that's what we have here. If we can dull at least the lights in the front just for a bit, it would be helpful because we could see a little bit more of this. Is there any way to do that? Okay, can you guys see the edges in here? Like that? Yeah. That outline here? Okay, so who wants to help me critique? I want you to self-critique then. What do you think?
I mean, I do the top of the skull. Like
Here's the pointer.
Like this part here.
Uh-huh.
You can't see it. So, I mean, I was standing up.
Right.
I did squat down at the beginning, but I didn't continue that. So, I was
Like for me, it would be easy.
Yeah. I mean,
Right, it's all about perspective, isn't it?
yeah. So I think I have a better, more accurate lower contour.
I think
Upper
you do
is,
too.
like, really wackadoodle.
It's not wackadoodle. What you've done is you've showed us your bias is your height. Because you're taller, you see over things that I wouldn't see.
Right.
So when I'm looking at it, I'm not seeing these, which, by the way, for those of you who care, this is the premaxilla. And this is the maxilla. If anyone here knows anatomy, they'll know what I'm talking about. Those of you who don't worry about it. We're talking about little bones in the front over here. These are the nostrils right over here. So in this sagittal image, that's this area right over here. This is the maxilla, and there's the premaxilla. And on her drawing, this is the maxilla. There's more premaxilla than is shown here. And the openings into the nostrils, which are here, you can see a little bit more here than you can on this because she's able to look into it. But what I think is actually even more interesting, and you probably didn't realize it because it's a little bit in shadow and hard to see, is this part right over here is where it connects to the vertebral column, yes? That's the occipital condyle. So that's the joint with the first neck bone. And you can only see a tiny, tiny sliver of it here in a true sagittal view. You saw more of this and not that. And when it's true on flat like that, this is kind of hidden by this piece over here. So this flange sticks way out, as you've got it, way out. But then this is tucked way in. And because you could look around the corner, like Alfalfa was doing in that picture, right? You look around the corner, you saw this. And you said, that's part of the skull. I want to put that out. I want to show the depth that there's something behind there. So as an artist, you incorporated it. And in a drawing where you want to show its connection to the vertebral column, that actually could be a plus. Because now it's there, and you can make that connection if that's what it is you need to emphasize. Whereas if it's missing, and someone were to draw it without that, and then all of a sudden there's neck bones there, the viewer might be like, but wait a minute. You've got to be connected. The head bone's connected to the neck bone. You've got to have something to connect to. And if you don't show it, it's a disconnect visually. And in terms of comprehension, you don't have that connection. So sometimes the artist needs to make exaggerations for the sake of comprehension. But it all depends on what is your goal. If the goal is comprehension, exaggerations are fine because they help us understand things, like cartoons, like the first talk we heard about. Cartoons are great for stuff like that because you can exaggerate just whatever it is you want to exaggerate to make the point. Whereas if it's for accuracy, if someone's going to actually do measurements on this and do reconstructions, then you're better off just using the digital photo. And then you just have to explain what's your perspective for that digital photo. Okay, I hope you had fun with that. Thank you.